Hello, welcome again to laboratory experiment in general chemistry. Today we will continue with unit 8, volumetric analysis. Volumetric analysis is the method of quantitative determination of species based on the measurement of the volume. It usually refers as titration, a technique in which typically the exact volume of unknown concentration of component X measured by the pipette and placed into a conical flask is reacted with the standard solution. The standard solution, whose concentration is accurately known, is usually gradually added to the flask from the burette. The reaction C plus X become A plus B is called a titration reaction. So look at the figure. The X is the unknown concentration. It usually measured by a pipette and placed into a conical flask. The standard solution usually pour into the burette. We call the titrant. And the unknown concentration as we call the analyte. The principal calculation is the law of equivalent proportion CC/VC equals CX/VX. The equivalence point is the point at which a complete chemical reaction takes place. At this point, equivalent quantity of the reagent are used. However, the equivalence point can only be estimated by observing a physical change such as a color change or clouding of the solution or turbidity of the solution. The point of titration when this physical change occurs equals the endpoint. Indicators are usually added to the analyte to give a signal of the endpoint. And how to check the behavior of the titration? We use a titration curve. A titration curve is a plot typically showing the change of logarithm of a concentration of the titrate solution versus the volume of the added standard solution titrant. The shape of a titration curve depends on the concentration equilibrium constant of the titration reaction. The inflection point, the steepest part of the titration curve, is the equivalence point. Instant change in curve when a small amount of titration is added is called the titration jump. Note that the equivalence point in acid-base titration will have the pH corresponding to the pH of the salt solution. In case the salt forms when a neutralize the strong acid by strong base. For example, we titrate the HCl and NaOH. The pH at the equivalent point is 7. While neutralizing the strong acid by the weak base or a weak base by a strong base, the pH at the equivalence point will differ from 7. This graph shows a typical titration curve of a quick acid. The red around here is the titration jump. We call the small amount of the titration is added, the instant change in the titration curve. Here is the equivalent point, the steepest part of the titration curve. So what is the requirement for the indicator? Look again at the calculation equation CC/VC equals CX/VX. The Vx of the unknown concentration solution measured by the pipette, we already know the volume. The standard solution, we already know the concentration Cc, and the volume of the standard solution in VC we read from the burette, the consumed amount. So from this equation we can calculate the Cx Theoretically, the VC, the volume of the standard solution, should be at equivalent point. However, in practical, we can only read the volume of standard concentration solution is the endpoint by the indicator. So therefore, the requirement for the indicator is the difference between the endpoint and the equivalent point is small to obtain a small error. Therefore, the endpoint should fall within the tangent jump. Is the requirement for the indicator. The endpoint should fall within the tangent jump to obtain the small error or small difference between the endpoint and equivalent point. So objective of this laboratory, we use test the behavior of two indicators, phenolphthalein and methyl orange, into tangent case when we titrate a strong acid by an NaOH solution, and when we titrate a weak acid by the sodium hydroxide solution. So what is the difference? So see you in the lab. Thank you for watching.